Welcome to our loan amortization exercise. There's many different ways to skin a cat in Excel, and particularly in finance, and you can do loan amortizations in different ways. I wanted to show one of the more detailed ways. Very quickly, I wanted to show an if statement first. So let's say yes, no, 1, 2. Because we will need an if statement for one of the items in this. So I'm going to say if this cell equals yes, then deliver 1. If not, deliver 2. So you can say this is the logical test. If that cell equals yes, and if you're dealing with words, it has to be in quotation marks. Deliver a 1. If not, deliver a 2. So if I change this to anything, it delivers a 2. More logically, if this cell equals 1, for numbers you don't need quotes, deliver, quote, yes. If not, deliver no. That example should be able to take you through. I'll leave this here in case you need to review the video. Now, let's assume we're buying a building for $10 million. And we're getting a loan amount based on an LTV of 75%. Remember, hard-coded assumptions are in blue. So we're going to make that blue, make that blue. Now the loan amount is going to be in black. So we take the 10 million and multiply it by 75%, get our appropriate formatting. Now, typically interest rates are calculated using an index and a spread. So you might have an index of 2.5% and then a spread over that the bank keeps of, say, 2%. Those are both going to be in blue. And then the total interest rate will be the sum of those two things. And let's fix the formatting here. For percents, we do 2 decimal places. Now, there's going to be a loan amortization period. It's typically either 20, 25 years, or 30 years. But we need the equivalent in months. So I'm going to actually change this label to show it in months and make it 360. Then we may or may not have an interest-only period where the bank says, okay, you don't have to pay interest for the first 6 months of the loan, maybe. Sometimes it could be longer, sometimes it could be shorter. Let's say for now that the interest-only period is 0, and we'll do an example where it is 0 and where it's not 0. So, and that's also going to be in months. And it has to be in blue. The loan constant we're going to come back to. The loan payment is going to be the interest rate divided by 12, since this is all in months, number of periods in months, the present value of the loan. We don't need the future value, so we've just put another comma, and it's going to be at the beginning of the period, so we put a 1. That's the monthly interest payment. Make this times 12. and that's what we pay in interest annually. I like to have it as a positive number. Then I can make it negative and add or subtract it, however I want to use it. Now, if you remember, we had our dates before, and I showed you some of those formulas. So let's start by doing the period that we're in. This is 0, and then we do +1. Period, beginning of period, end of period. Go back here, +1, and we copy this down all the way down until we have 360, because that's where the loan will end. Now, we'll say that the loan gets funded 12/31/2020, and we'll use that EO month formula that I showed you before, and just make sure, and we're going to use the format painter. So we get the same format, and we use +1, and the E-date formula. And there we go, we are off. Our beginning balance is going to be linked to our loan amount. Interest payment for now is 0, 0, 0. We have no payments in period 0. Ending balance is going to be equal to the beginning balance here. Now, in period 1, the beginning balance is equal to the ending balance of the previous period. So we take that, make these blue for now. While there's multiple ways to do an amortization schedule, I'm going to take the simplest way for now. So we take the beginning balance of the loan at the period in which we start payments, which is period 1, and multiply it times the interest rate, lock that cell, and divide by 12. And then I'm going to take the payment function, take the rate, divide by 12, and we're going to lock that cell. Take the number of periods, lock that cell, the present value of the loan, lock that cell, the future value, and Excel's default is the end of the period for loan payments, so that's what we're going to have to use to get this correct. And I'm going to make it a positive number, just because that's how I like to operate. So that's our loan payment. Then we take the total payment minus the interest payment, and we have our beginning balance minus our principal balance. Then if we drag this down, make sure everything is correct, we drag this down all the way to the end. Period 3, 360. And as you can see, at the end of 360 months, our loan is paid off. Now, there are certain tricks that you can do for this, and I will show it on the next sheet. This is the standard loan amortization schedule that you would build in Excel. Next, I'm going to make it a little bit different by using some of the Excel finance functions and by adding some interest only. Okay, so now we're going to continue with the rest of the amortization schedule. There are a number of different ways to do this, as with everything in Excel. But for now, I'm just going to take the most standard way. So I'm going to take the beginning balance for the period times the interest rate. I'm going to lock that cell and divide by 12. Then I'm going to use the payment function. iPayment is the interest payment function. So you've seen the payment function before, I believe. Now, this is just the interest payment for the period. So there's more than one way to do this. So I think in this case, the best way to do it is to calculate what the total payment is on the loan. While you can use that interest payment formula, the best formula for our sake is to just take a percentage of the loan balance for the beginning of the period and multiply it by the interest rate. Because we're going to be using the interest only formula, we need to start it with an if statement. So we're going to say if the period that we're in is less than or equal to the interest only period, and we're going to freeze that cell, then the interest payment is going to be 0. And if it's greater than that, meaning if it's false, it's going to be the loan balance times the interest rate divided by 12. And then what we're going to do is we're going to take the payment formula